All right, let's take a look at 2.4f, composition of functions defined by equations. Oops. So let f of x equal square root of x, let g of x equal 3x plus 2, and h of x equal x squared. Find each composition function and state its domain. So first they want f of g of x, and this is going to be, again, it means this, f of g of x, or some people say f after g. But again, I'm going to go ahead and write the outside function first, because we are kind of starting with g, but it's going to go into the f function. So I'm going to write the f function, but instead of x, I'm going to put a big old parentheses. Now I'm going to take the g function and place it in the f function, and now I've composed the functions. What I'm going to do next is simplify if I can. Well, I can't do anything with that, but now they want me to identify the domain of that new function. So I'm going to take a look at the number line idea that I referred to a couple of videos ago, and I'm going to ask myself, can any negative number go in this position here into the x? Okay, so we can tell that if we got a large enough negative number, or actually just basically a negative number is going to cause this to be a negative, and then the square root of a negative is not a real number. So let's take a look at what number would be the dividing line between the negative and positive under that radical. Okay, so let's take a look. What I want is I want the 3x plus 2 to actually be greater than or equal to 0. I want it to actually be the dividing place. I want it to be the 0, but I want it to be either 0 or greater. So I'm going to just go ahead and solve that inequality, because I want under the radical to be 0 or bigger. So I'm going to force it to be 0 or bigger. Divide by 3, divide by 3. X is greater than or equal to negative 2/3. So the largest negative number that I'm going to, the smallest negative number that I'm going to be able to put into this x position is negative 2/3. So that's my negative 2/3 is the kind of the dividing line between what's going to be real, which would be over here, and what would be imaginary, which would be here. So this is not going to be okay. I'm not going to be able to have anything less than negative 2/3. So would I be okay with putting in a 0 into that position right here? Certainly, it would be fine. Would I be okay with putting in any positive number? Certainly. So this indeed is my domain. I'm going to go ahead and write it as an interval notation would be negative 2/3, including negative 2/3, but then going on to infinity, and that would be my domain for that new function. Okay, let's take a look at another one. We're going to take a look at g of f of x. So I'm going to again write what it means. It means to put in the f function into the g function. I'm going to write my g function first, putting in a big parentheses instead of the x. Now I'm going to dump in the f function, which is the square root of x. And now, if I could simplify, I would, but I can't do anything with that. And again, I'm going to go ahead and create my number line so that I can find my domain. Alright, so is it okay to put any negative number into that function? No, it's not. Is it okay to put a 0 into that function? Yes, it is. Is it okay to put a positive number? Yes, indeed. So my domain ends up being from 0 to infinity. Okay, and one last one. We're going to take a look at the composition of h of g. H of g. So I'm going to go ahead and remind you that that just means this. H function is going to be used to place the g function in. And so let's take a look back up here. The h function is this. Okay, there's my putting my parenthesis. My x is going to turn into parentheses. Now I'm going to put the g function in there. Alright, and now I'm ready to simplify. Now this means that I must FOIL to simplify. So I'm going to get 9x squared, and that's going to be plus 12x. This is just foiling. I'm just simplifying it quickly. And so there's my function. And then, of course, my domain. I'm confident that negative numbers are fine, so I'm going to put negative infinity to infinity, and that is my domain in interval notation. All right, hope this is helpful. Thanks for watching.